right, good afternoon. Okay. So, um, so we're talking about our. Thank you for plugging the art video again. Check it out. um, we did some just like basic doing the inequalities. Am I going golfing today? I don't think so. Should I be? Maybe. I look like it. Is this your pretty typical golfing outfit? Just because is the hat? Is it literally this has to be because of the hat, right? Bow tie, t-shirt, hat. I don't think that's what people wear when they go golfing. Bow tie, t-shirt, hat. I don't think so. Is there anyone else here? Yeah, we got Finley here. We got I think Matt's here. I think we got we got a handful of people here as I'm reading off the side. The other is okay. Well, but I wear a hat like every day almost. So how come you never tell me that I'm going golfing when I wear the other hat? What about this hat makes it a golf hat specifically? Matt is always here. It's your birthday. Happy birthday, Finley. Big shout out to Finley. It's Under Armour. True. Well, this stream is just sponsored by Under Armour, so that's why I had to bust out the Under Armour stream today. Yeah, don't type all caps. Yeah, but happy birthday, Finley. 17? Should be, right? Coronavirus. What? Oh. So, Finley, where are you having your virtual birthday party at? Where should we all go? Are you just going to send us the Zoom invite or like what? Perfect. Perfect. Or tailgate party at South. Okay, well, see. A lot of good options. Maybe at the golf course. Could be good. Golf courses are closed. Yeah, that's fine. You know, Park Hill South is also closed. Not all of them. Are there some that are open? I don't know. I knew it. Whacked him. All right, let's get these examples done. All right, so we're going to talk about our next topic, which is related to systems of equations. So we're still talking about them, but which is called partial fraction decomposition. Right. So really, the idea of this is we want to take a fraction and break it up into multiple different fractions. Okay. And here's the steps that we're going to use to do that. We're going to factor our denominator completely. We're going to create a fraction for each factor of the denominator with a variable in the numerator. We're going to combine fractions by using an LCD, simplify, rearrange, and create a system of equations, and then we're going to solve. Now, do these steps mean much of anything, just saying them right now? No. But once I show you how to do them, then you can look back at these steps and go, oh, okay, yeah, that's what we were doing, or if you forget later on. So, but like many of our steps for various things that we solve, we often start with factoring. Okay, so for our first example, let's decompose this fraction using partial fractions. So our first step is to factor the denominator. So I'm just going to do that off to the side. So that would be x minus 4, x plus 3. Okay. So next step, create a fraction for each factor of the denominator with a variable in the numerator. All right. So we have two distinct factors. Right. And so, I'm also meant to say for everybody, this is something that is brand new to everybody. Right, to college algebra. People who were in college algebra last year did not learn this. People who, if you just came from algebra 2 or trig, you haven't learned this yet. Okay, so this should be something that's brand new. However, it relies on using systems of equations, but we just have to do some different setup steps to get there. So we have two distinct factors here, x minus 4 and x plus 3. So I'm going to rewrite this again. So, like it said, I'm going to create a fraction for each factor. So I'm going to create a fraction that has x minus 4 on the bottom. And I'm going to create a fraction that has x plus 3 on the bottom. Now, the question is, all right, so you can see kind of the general goal of what we're trying to do. I'm trying to take that fraction on the left, and I want to split it up into two fractions. One with the denominator of x minus 4, one with the denominator of x plus 3. The question is then, what is it that goes up here that makes it so that these two sides of the equation are actually equal? All right, so we're trying to figure out what goes there. Well, let's not use question marks. So let's instead, we already have an x, so let's just use A and B. Okay, we'll typically just use like A, B, C, D. Capital A, capital B, capital C, capital D. Okay, next step. I have to use an LCD. Okay. So let's actually multiply everything by our LCD. You probably can't see the edge of that. Whoa. Think a little bit better. Okay. Let's multiply everything by the LCD. This is kind of like what we did with, oh shoot, what was it called? Solving rational equations. All right, so this LCD gets multiplied by every single piece here. All right, so for the left side, that just cancels everything from the denominator. All right, because the denominator, x squared minus x minus 12, that's the same thing as x minus 4 times x plus 3. So that would cancel. Right, for this term, the x minus 4, I would have in the denominator and in the numerator. So those x minus 4s would cancel. Whoa, not highlighter. Leaving me with just a times x plus 3. And then, so move over to the next term here. This x plus 3 would end up canceling, leaving me with just b times x minus 4. All right, that's a really critical part here. So if you don't understand what just happened or where pieces went or what canceled or why a certain number showed up, say so now, please, because that's a really important part. Megan understands it. Okay. All right. Trust. Next up, simplify, rearrange, and create a system. Okay, so what does this actually mean? The first thing I'm going to do is actually take these. Does Matt? I don't know. Matt, he's always here. So ax plus 3a plus bx minus 4b. Matt does understand it. Thank goodness. I always believed. Mr. Langdon. What is that, 8th grade? 7th grade? 6th grade? 5th grade? 1st grade? Preschool? The doctor that delivered you? Who? 8. Okay, so from here, what we're going to do is rearrange so that like terms are together. All right, so for example, the ax and bx, I'm going to group those together. The 3a and the minus 4b, I'm going to group those together. And the left side, I'm just keeping the same. Looking at those first two terms, 8x plus bx, I'm going to go ahead and factor out an x since they both have that. Uh, 3a minus 4b Nothing in common, so I'll just leave that as 3a minus 4b. I'll go ahead and put those in parentheses, though, just to kind of signify to myself that those are grouped together. Okay, so for each side of this equation, let's really look at what I have. I have negative 3x on the left side and a plus b x on the right side. So now this is the point where I can create a system. Right? Since these are the only terms that have x in them, what I can determine then is a plus b, whatever those two numbers are, when I add them together, it has to be negative 3. Right? Since those are the coefficients of x, if the left side is the same as the right side, then whatever a plus b is, it needs to be, whatever the numbers are individually, whenever I add them together, I have to get negative 3, because that's what the left side is. Okay, so I'm going to create an equation out of that. So a plus b equals negative 3. And then when I look at the 3a minus 4b, those have to be the same thing as negative 23, right? In order to ensure that the left side of the equation is the same thing as the right side of the equation, those two purple things that are highlighted need to be the same. So I can create another equation. Three a minus 4b, whatever a and b are, has to be the same thing as negative 23. And now that we've created a system of equations, we can solve this, right? We can solve this using elimination or using substitution. Either way is fine. I would say since that first equation is just a plus b, and neither of those have a coefficient, probably wouldn't be too difficult to just solve this by substitution. So I'll just rearrange that. So a equals negative 3 minus b. And then we'll go in and substitute this in for a. So 3, but instead of a, negative 3 minus b minus 4b equals negative 23. And then we just solve for b. So distribute the 3, negative 9 minus 3b minus 4b equals negative 23. Oops. Add 9 to both sides, we get negative 14. So negative 7b equals negative 14. Therefore, b equals 2. And if we know b equals 2, then we can go back into our first equation up here, or either one of the original equations, and just plug in b. So a plus 2 equals negative 3, which means a must equal negative 5. So I'm pretty much done with my problem. Now again, we have to go back, what are these numbers, what are these actually for? So if we go back to what we originally wanted, the whole goal was if I split up that fraction, a and b are what those pieces are in the numerator. So a over x minus 4 so wait, what was the original problem? x squared minus x minus 12. A over x minus 4, so negative 5 over x minus 4, plus b over x plus 3. Yeah. Oh, wait. Why did I put b? 2. B is 2. We know that. This is the fraction that we started with. And then these two fractions is what we ended with. So again, our goal for partial fraction decomposition is to take a fraction that is more complicated, or specifically that has a more complicated denominator, right? The denominator is x squared minus x minus 12, and splitting that up into two separate fractions that have much simpler denominators, x minus 4 or x plus 3. Individually, those are much more simple. So this will be useful to us in calculus, where we have different types of problems that we want to do with that first original fraction that we had, but it's a little too complicated for us to handle. So instead, if we rewrite it and split it up using partial fraction decomposition, it's much easier to do the process that we want to do if those denominators are just x minus 4 or just x plus 3. It makes our lives a lot better. So that's what we'll mainly use this for, is in calculus in the future. I'm Mr. Abundus. Okay, let's try again. All right, first up, I need to factor the denominator. They don't go to our school. Okay, so factoring, the only way I can factor here is by using a GCF. X squared times x minus 4. So I'll rewrite this. Now, here's a slight change. So again, I want to create a denominator, but here's the denominators that I need to make. And then I'll go A, B, C. So here's what's something different from our last problem. If whenever we factor, we still have a squared. Okay, on our last one when we factored, it just factored into x minus 4, x plus 3. There was no squared after we factored. Here when we factor, it's still squared. So if we end up with a squared term, then what that means is we need to have the linear version and the quadratic version of that term. Okay. Or I guess not even just the linear and quadratic, but every exponent leading up to whatever it is. So for example, let's say I ended up with a x cubed there. Then in my denominators that I make, I'd have to have a denominator that just had x in it, I'd have to have a denominator that just had x squared in it, and I'd have to have a denominator that is x cubed in it. Right? Or if I factored and ended up with x plus squared, I'd have to have a denominator that is just x plus 1, and I'd have to have a denominator that is x plus 1 squared. So if after you factor, you still end up with exponents of some kind, then you need to create a fraction, a denominator that has each of those degrees leading up to whatever you ended up with, if that makes sense. Right? It's kind of, I'm trying to word it the best way that I can. I don't know, is that resonating? Sure. Okay. Seems like no. Okay, let me give you some more examples. We won't actually do these, but I just want to show the writing out part. So let's say 3 over x plus 3 squared, x plus 2 squared. So whenever I write these out, so I'd have to have x plus 2 and then I'd have to have a denominator for x plus 3 and a denominator for x plus 3 squared. All right, you have to start with the factor just with the power of 1 and then create another one for each one. So for another example, let's say, I'm just making up these numbers as I go. Okay, let's say x minus 3 to the 4th, which would be crazy, but whatever. So I'd have to have a denominator that's just x plus 5. And then since everything else is just x minus 3, so I'd have to start with just normal x minus 3. And then I'd have to create one that's x minus 3 squared. And then I'd have to create one that's x minus 3 cubed. And then I'd have to create one that is x minus 3 to the 4th, because when we factored, it was all the way up to the 4th. Is that better? Maybe. At least in understanding what we're doing, maybe not why we need to do that, but just that is what we need to do if we end up with an exponent after we factor. Okay. Cool. Okay, great. All right, so that's exactly what we did here. All right, we factored and we got x squared, so we had to kind of use each built-up version, just x to the first and an x to the squared. X squared, x to the second power. Okay, next up is we multiply that by the LCD, which the LCD is just this denominator, basically. So I can't write any more off to the side because you won't be able to see it, so I'll just write it down below. Or I guess maybe it'd be better to write it above, that way I could write the distributing. All right, so it distributes everywhere into all of the numerators. On the left side of the equation, it's the same thing, so it should cancel all of the denominator and just leaving me with this numerator. Okay, on the right side, one of these x's will cancel, which would leave me with ax times x minus 4, because there was an x squared in the numerator, but so one of the x's canceled with the x in the denominator. X squared will cancel, leaving me with just b times x minus 4. X minus 4 will cancel, leaving me with just C times x squared. All right, so I'll pause here again. The opportunity at this point, am I losing you? Am I good? That red LCD gets distributed to each term, and then certain pieces cancel. Who'd you lose to? Charlie Parsons. That was the one I was trying to go for the big 6 in a row, and it didn't work out. But I stick by my decision. If you have an opportunity for 6 in a row, I think you got to go for it, and I went for it. It was a dangerous play, but I wanted it. Why can't we subscribe? Because I don't want to get paid by my students. I think that would get me fired. I done got it, man. True. It's free. Not really. Free. Somebody is paying $120 a month or a year to have Amazon Prime, right? It's not free. Right. Megan has Amazon Prime. So if I enabled subscribing, then Megan, if you wanted to subscribe to me with your free month of Twitch Prime, but again, just the idea in general, even though Twitch Prime makes it a little easier, but let me log out so I can't see my birthday presents. Yeah, but still. So here, think of it this way. If I were at school and you guys walked up to me and said, "Here, Mr. Abundance, here's $2.50." I would not accept that. So even though it's now online and sort of through Twitch, it's not a direct handing me money, but it is still basically like you're handing me money, and that's no go. For emotes. Yeah, Ted, I know. That's the thing that I wish. That's the thing that sucks, because if I enable that stuff, we could have cool emotes for subscribers, but I don't know. I just can't do it. Friday Night Lights, the movie or the show? The show. No, I only saw the movie. I've seen like random episodes of the show whenever like I've been at other people's houses and they've had it on or something. I'm not paying more to sub. True, but I'm just saying it makes me feel a little uncomfortable. It makes me a little worried. Watch it. It's addicting. I'll look into it. I don't know. I feel like I've always heard good things about it, though. Can't you guys take sick days and get virtual subs? That's a good point. I'm actually going to talk about that a little bit later. But let's finish up this problem, and then we can talk about Twitch Prime and Friday Night Lights and subs and everything. All right, so let's distribute. Okay. So now, like before, I want to go through and group things together that are like terms. So, for example, ax squared and cx squared are like terms, so I'll group those together. ax squared plus cx squared. Minus 4ax and bx. And then lastly, we just have a minus 4b, so minus 4b. Now, just like before, I'm going to factor out those variables, or not, well, not all the variables. I'm factoring out like the x's specifically. So this factors into a plus c x squared, right? Just GCF. I'm going to factor out the x from these two pink terms. And then the minus 4b has no variable to take out, or no x to take out of it, so I'll just leave it as minus 4b. Okay, so now we can look and compare the left side and the right side. So let's first look at the x squared stuff. So on the left side, I know that the answer, the goal is that this should be 4x squared. So what that does is I look at the x squared on the right side, the coefficient is a plus c. So whatever a and c are, when I add them together, I should get 4. All right, now I look at the x variable on both sides, and I look at the coefficients. So negative 4a plus 4b should be the same thing as negative 11. So I'll create another equation from that. And then lastly, minus 4b should be the same thing as positive 12. So I've created a nice system of equations. And now it's just solve. So you can, again, solve through elimination, solve through substitution. But if we look down here at this last equation, I would start here since it's just b. So divide both sides by negative 4. So b is negative 3. Let's plug that into our second equation. So negative 4a plus negative 3, so minus 3 equals negative 11. Negative 4a equals negative 8. A equals positive 2. Now I know a, so I can plug a into that first equation to figure out c. So a plus c, 2 plus c equals 4. C equals 2. So I have to actually write the full decomposition now. forgot. I have to scroll up and down a lot. 4x squared minus 11x plus 12. So 4x squared minus 11x plus 12. And my denominator was x cubed minus 4x squared. Right, equals. So I remember I had the three fractions. So A, B, and C. So A was positive 2. B was negative 3. And C was positive 2. And where did the denominators go? X squared, x minus 4. Okay. Boom. So again, what we've done is we've taken a much more complicated fraction and we've broken it apart and split it up into three fractions that are individually, these three fractions are much more simple. Right? The numerators are just numbers, 2, negative 3, positive 2. And the denominators are not multiple factors, right? It's just x, or just x minus 4, or just x squared. So again, for processes and things that we want to do in the future and in calculus, this right side with these three fractions is going to be much, much better for us. Makes stuff a lot easier. I guess also, since that middle term is negative 3, we could also write this with a minus sign between them right there. That would be the same thing. Okay. All right, so that's the first half of our lesson. We'll pause there, and we'll come back and finish that off later. So speaking of sick days and virtual subs, we're not going to have a live stream tomorrow. I'm going to go ahead and take the day tomorrow and finish and get caught up on grading and everything. Right? I've had like all of my classes turn in performance tests in the past couple days, and so I'm going to get that all sorted out and go through and grade and get the grades entered and up to date and checkpoints and whatnot. So yeah, we won't have live streams tomorrow.